Hi folks, so I'm going to take a look at page 170, number 13. So here they're giving us two functions that are both increasing on an interval AB and that are both strictly positive on the same interval. And they want us to show that the product of these two functions is also going to be increasing. All right. So here, let's recall what it means to be an increasing function. So it means that if I've got, my interval AB, that I can pick any two numbers in this interval, say I call them x1 and x2, and the y value at x2 is going to be larger than the y value at x1. Okay, and as long as I can show this for any two values in the interval, then it'll be increasing on the whole interval. All right, so let's just see what we have to show. Okay, we have to show that if I take any x1, x2 in the interval AB, okay, such that, and again, I'll make x2 the bigger one, x2 is bigger than x1, then since I'm looking at the product, I need to show that fg at x2 is going to have to be bigger than fg at x1. All right, this is what we have to show. Okay, so again, we're going to assume that x1, x2 are any two values in AB, and we're just going to let x2 be the larger one. Okay, so what I do know, though, is that f and g are both increasing. So let me start with f. Because f is increasing, I know that f at x2 has to be larger than f at x1. Okay, so I can say that, and I should be justifying my steps here. I can say that because I know f is increasing. Okay, so regardless of what x1 and x2 I take, this must be true. Okay, so eventually, though, I'm going to want to end up with f at x2 times g of x2, which is the how we define this product here. Okay, so what I'm going to do is I'm going to multiply this by g at x2. Okay, but of course I can't multiply one side of an inequality and expect the inequality to hold, so I'm going to multiply the other side of the inequality by the same thing. Okay, but this is where we have to be careful, because we know that when we're dealing with inequalities as opposed to equations, we can't necessarily multiply both sides of the inequality without checking that the inequality isn't going to change. But let's recall that they told us that f and g were both positive. So in particular, g at x2 must be positive. So if I multiply both sides of an inequality by a positive number, the inequality is going to hold. Okay, so let me justify that here. This is since g of x2 is a positive number. Okay, so now let's take a look here, because I don't want f at x1, g at x2. I want f at x1, g at x1 on the other side of this inequality. But these are all positive numbers, and g of x1 is a smaller positive number than g of x2. So if I replace g of x2 by a smaller number, it's going to make the whole expression smaller. So this f at x1, g of x2 is going to be larger than f at x1 times g of x1. Okay, now I can only say this, again, because I know that g is increasing, so g of x2 has to be bigger than g of x1, and because all of these numbers are positive. Okay, this might not necessarily work if I was dealing with some negative numbers here. Okay, so this part of the inequality is true since g of x2 is greater than g of x1, and because everything here is positive. So f and g are, any values of f and g are always going to be positive. All right, and this is where we're going to use a principle here, which we're going to take as being reasonable, that if I call this A, B, and C, what do we have here? We have that A is larger than B, and B is larger than C. So we can infer that A is larger than C. So in other words, okay, f at x2 times g of x2 will be larger than f at x1 times g of x1. Okay, in other words, fg at x2, which is what this is defined as, is going to be bigger than fg at x1. which is exactly what we wanted to prove. And since there were no conditions on x1 and x2, other than they were in the interval and x2 was the larger one, we've proven what we need to prove. All right, so let's just recap here how we figured out what we needed to show in order to show that FG was increasing. We started off with one of the pieces of information we were given, and then we could do this sequence of inequalities to show what we needed to show. But I want you to see here how all the components that were given to us were necessary. So we needed the fact that F and G were increasing. We used this here as our starting point, and then we used it for our second inequality. And we needed to use the fact that F and G were both positive, first in the first inequality, and secondly in order to infer the second inequality. All right, that's it for this one.